Hello students. Welcome to the third class on digital image processing. Hope you're all doing good and have gone through the first two lectures. In this class, we'll be basically focusing on the fundamental steps in digital image processing. So what are the various steps involved in processing a digital image? Starting from below, what you can see here is the image acquisition, the image filtering and enhancement, image restoration, color image processing, wavelets and other image transforms, compression and watermarking, morphological processing, segmentation, feature extraction, and image pattern classification. So these are the various steps involved in digital image processing. The first thing is about image acquisition, where the idea is to just acquire the image and convert into digital form. The steps from image filtering and enhancement till the morphological process results in the input image being transformed into output also being an image, but in a better form. The other steps involved from morphological processing, including morphological processing till image pattern classification, involves the input being images and output could be some attributes. So this could be your, the medial level processing. As I've told you in the first video lecture, that you can have low level image processing, middle level image processing, and high level image processing. So the first few steps involved are the low level image processing, and the next involves your middle or the middle level image processing. So today we will see these steps one by one. So basically, digital image acquisition is the process of creating a digitally encoded representation of some visual characteristic of any object. It could be some scene which you are able to see. So we want to acquire the scene element as a digital image. Okay, so that is the process of image acquisition. Also, image acquisition could be as simple as being given an image that is already in digital form. So generally the image acquisition stage also involves pre-processing techniques such as scaling, etc. So what you see in front of you is about image acquisition simple process which can be easily understood. So you have you should definitely have a source of illumination if you want to acquire an image. So which one falls on a element which is to be seen, so that can be taken. So when if only in the presence of some illumination, a seen element can be acquired using some imaging system, and this can be projected onto some internal image plane, and this could be outputted as a digitized image. So the digitization can depend on the components or the various processes involved in the conversion process. So the next step is image enhancement. A brief of image enhancement was already explained in the first video. So as the name suggests, enhancement, so it is a process of manipulating an image so that the result obtained is much more suitable than the original for a specific application. Usually here the final judge is you and me, that is how better it is in terms of visual appearance or visual perception. So as you can see in the image in front of you or the picture in front of you, the second image of the board or the my processor is looks much better for a visual interpretation than the first image to the left. So when we speak of that, the image enhancement helps in making the image better for a suitable specific application. What we should understand here is, suppose some image enhancement technique which could be better for say X-ray imaging need not work equally for infrared band imaging. So it depends on the application where you apply the image enhancement technique. So finally, we should understand that there is no general theory of image enhancement. So it is basically a process for visual interpretation. So the viewer is the ultimate judge of how well a particular method works. So finally, it should be better for a visual interpretation. There are many image enhancement and filtering techniques available. So you will study again more of this in the upcoming chapters. So coming to the next step, that is image restoration. So sometimes what happens is an image could be degraded or some noise could be present. So we want to restore the original image. So even this example, a little different example was given, but the same technique have already explained in the first video, but a different picture I have used. That's it. So in image restoration, here the restoration technique, it is based on mathematical or probabilistic models of image degradation. So here it is based on human subjective preferences regarding what constitutes a good enhancement result. So here also it is important in terms of how the human eye can perceive it, and that we are the best judges of telling whether an image is restored properly based on whatever technique that can be used. But to repeat, image enhancement is based on mathematical or probabilistic models of image degradation. So you want to restore a degraded image. So the next one is color image processing. As we all know, color image processing is gaining wide importance because of the significant increase in the use of digital images over the internet. So there are different color models used and which will be studying in this subject. So you might have heard of RGB, which stands for red, green, blue. Similar to that, there are other color image models such as HSV, that is hue saturation value, HSI, and so on and so forth. There are different color image models which you will be studying. So this is also one of the fundamental steps involved in digital image processing. The idea behind using different models, image models like HSV and all, is to extract some of the features that is contributed due to the color. As you know, different color means different wavelength. Same way, there is something to do with the hue, saturation, value, intensity, etc. So it's not only RGB color models, there are other color image models too. So we'll be using these color image model attributes to gain some parameters or information, and subsequently process in the color using the color image processing. Next, coming to wavelets. You may be new to this term. So what are wavelets? To speak of wavelets in general terms, they are nothing but short duration wave-like oscillations or brief oscillations of short duration. There are different types of wavelets available. So some of them are shown in this figure, something like the Haar wavelet, Gaussian wavelet, Morlet wavelet, dB wavelet, biorthogonal wavelet, etc. Now, these wavelets are the foundation for representing images in various degrees of resolution. So, by using wavelet signal processing or wavelet processing, we can represent images in various degrees of resolution. So, this is one of the advantage of wavelets. You'll be studying briefly about this in this subject on digital image processing. So, the next thing is compression. You might have heard of these formats like JPEG, TIFF, GIF, BMP, PNG, and so on. Definitely when you save an image, it would have asked you which option you want to save. So all these are formats in which the image can be stored, basically in the form of compressed image formats. So compression, as the name implies, deals with techniques for reducing the storage required to save an image or the bandwidth required to transmit it. So although you can see here that in a lossy image example, the first image, second image and the third image, So from the original image to the highly compressed image, lot of information is lost. So this is an example of lossy compression, just to give you some information. Same way, there's another type of compression wherein that is called as lossless compression, where virtually that is visually we will not be able to feel that information is lost, though, but the size wise the information is compressed. Although you will not be going to much details of this in your subject, for your interested, if you want to know more, please explore about this. However, nowadays with the increase in AI, that is artificial intelligence, it is possible even with lossy compression not to lose the quality of an image. So AI machine learning has improved the compression to higher extent, with a less number of loss of less in loss of information. So next, coming to morphological processing. This processing actually deals with tools for extracting image components useful in the representation and description of shapes. So here the input can be image and input should be an image, and output can be image or an attribute. So if input is an image and output is an image, we speak of low level processing. And if input is an image and output is an attribute, we go to classifying it as mid level processing. So what you observe here in the figure is when input is an image and output is also an image. Here you can observe that based on the shape, the filtering is done or the morphological processing is done. So I've already told in the introductory video that we use some processes or tools like erosion, dilation, etc. We will be learning more of this in the future modules. The next step is image representation and description. These steps actually follows the output of a segmentation stage. And by doing so, that is by suitable representation of the image, we are actually converting the data into a form suitable for computer processing. And by doing so, we are helping in the next stage, that is the pattern or the object recognition in the given image. In image representation, the first decision that must be made is whether the data should be represented as a boundary or as a complete region. Speaking of boundary, the boundary representation is appropriate when the focus is on the external shape characteristics such as the corners and inflections. Speaking of the region or the whole region representation, the regional representation is appropriate when the focus is on internal properties such as texture or skeletal shape, etc. In some applications, these representation, both in the form of boundary or complete region, both complement each other and both are necessary. However, choosing a representation is only a part of the solution for transforming our raw data into a form suitable for subsequent computer processing. Next, The image description. Description, or also known as feature selection, it deals with extracting attributes that result in some quantitative information of interest, or basically figuring out the basis for differentiating one class of objects from another. The next process or the next step is recognition. So what do we do in recognition? This is the process which assigns a label to an object based on its descriptors. So as you can see here in the example, we have segmented the objects or region of interest. Other than that, we have also assigned labels. For example, car, truck, traffic light, person, bicycle, etc. Here, the input is an image and output is an attribute like the traffic light, truck, car, etc. The next most important component is the knowledge base. This is the same figure what you saw in the first slide on fundamental steps in digital image processing. In the center, you saw that everything is connected, or each of the step is connected to something known as the knowledge base. So far, we said nothing about the need for prior knowledge or about the interaction between the knowledge base and the processing modules. However, knowledge about a problem domain is coded into an image processing system in the form of a knowledge database. So this knowledge may be as simple as detailing regions of an image where the image or information of interest is known to the located, thus limiting the search that has to be conducted in seeking that information. The knowledge base can also be quite complex, such as interrelated list of all major possible defects in a materials inspection problem, or an image database containing high resolution satellite images of a region in connection with change detection applications, so on and so forth. So to say in brief, a knowledge base is having a rich database of all the information that can help in the image processing steps. With this, we end the topic on fundamental steps in digital image processing. The next topic is to understand the various components of an image processing system. The slide or the pic which you can see in front of you demonstrates the various components of the image processing system. They are the image sensors, the specialized image processing hardware, the hard copy, the image processing software, image displays, computer, mass storage, network, and the cloud. Now let us go into the few of the details of each of them one by one. Anytime when you feel like, you can pause the video and make notes. This is for throughout the video. Speaking of the first component is the image sensor, what you can see below. When we speak of sensing, we need two elements to acquire the digital images. One is the device, basically like a sensor, which is sensitive to the energy radiated by the object we wish to image. So we speak of it in terms of a sensor. The other element is nothing but a digitizer. A digitizer is a device for converting the output of a physical sensing device. That is, we are converting the output of a sensor, which will be in some form, in the form of say electric current or voltage, and that is converted into some digital form. For example, in a digital video camera, the sensors produce an electrical output, and which is proportional to the input light intensity which is emitted from the image, or emitted from the object of interest. Now the second element, that is the digitizer, it converts these outputs to a digital data. All this will be studied in detail in the next chapter of the module. Speaking of the next component, that is the specialized image processing hardware. Now what is this? Speaking of the specialized image processing hardware, so this hardware contains, one part of it is the digitizer, which just spoke about in the previous component, Along with that, it has a hardware that performs some other primitive operations. It could be some arithmetical and logical operation that is can be performed by the ALU, and it is done parallel on the entire images. One example of how an ALU can be used is, in averaging the images as quickly as they are digitized for the purpose of noise reduction. So for noise reduction, such operations, such arithmetic operations can be used. This type of hardware is sometimes known as the front end subsystem. Okay, and its is used is a distinguishing characteristic is its speed. So this unit or something like an example ALU, it performs the functions, or this hardware, it performs the functions that require the fast data throughputs that the typical main computer cannot handle. Next, speaking of the computer, here we are speaking of a general purpose computer. And this can range from a normal PC to a supercomputer. Depending on the application, or in a dedicated application, sometimes the custom computers are used to achieve the required level of performance. Next, coming to the image processing software. Nowadays, just forget about what is there in the textbook. So many image processing softwares are available. You also use MATLAB, you also use Python, so on and so forth, right? So basically, this software for image processing, it consists of specialized modules that perform some specific task. In the coming slide, I'll be speaking about mass storage, hard copy, image displays, network, and the cloud. Mass storage is a must for image processing applications. Why? So consider an example wherein an image has 1024 cross 1024 pixels, and think that each pixel is stored using 8 bits. Then what amount of space is needed to store the image? Of course, 1 MB of space is needed. This is when we are speaking of one image. But what if there are thousands of such images? So of course, mass storage is that's why very important in image processing application, and thus a challenge. Of course, that is why we go for many compression techniques, right? So the digital storage for image processing applications, it falls into three principal categories. One is for short-term storage, just for the processing, and then we don't store it anymore. Or online storage for when you want to go for fast recall or fast access. And then is archival storage. This is when we don't use it frequently or infrequent use or access. That is why it's called archival storage. Of course, nowadays we don't bother too much about mass storage because buffers or even cloud is used. So that's why I think that's why of course you know that nowadays storage in the cloud is not or storage basically of images or even videos is not a big problem nowadays. But previously mass storage was always a big challenge. Of course, now also it is quite a challenge, but we are speaking now in terms of terabytes and exabytes of storage. But previously they were speaking in terms of gigabytes and megabytes of storage. Speaking of image displays, what are image displays? Any display that can display an image. It could be a TV or any other monitor. Of course, with these monitors like your computers, monitors or desktops, they use graphic display cards for displaying images. Next, speaking of hard copy devices, these are the devices that are used for recording the image, and this can include laser printers, film cameras, hard drives, disks, CD-ROMs, etc. Coming to networking and cloud. Networking and cloud is almost a default function in any computer system in use today. You people are very well used to this kind of networking and the cloud. Of course, this is because large amount of data is inherent in image processing applications. This is the key consideration in image transmission is the bandwidth. In dedicated networks, this typically is not a problem, but communication with remote sites via the internet are not always as efficient. Of course, nowadays you use the cloud. Fortunately, this situation is improving as a result of optical fiber, cloud, and other broadband technologies. So this ends about the topic discussion on components of image processing system. Of course, there is lot of improvement and scope going on these days, and many more components or relative components are added in an image processing system. So I hope you have all understood this topic, and if you have any doubts, go back, pause the video and listen to it again, or read the textbook. Or if you want to ask doubts, please personally text me or call me or mail me. Thank you.